Good day, Gretkov. So we are attempting a question, a periodic table, okay, for November 2019, grade 10, November 2019. So let's go through it and see. Now we are told that a section of a periodic table is shown below. Imaginary symbols are used to represent some of the elements. So here you're not required to understand to know which one is E, which one is A. No. You just need to understand, all right, no, these are my metals. These are my group 1, group 2, okay? So these are what we call the metalloid. Then here we have got nanometals, just like that. Then the last part here, you just know that that's your noble gases or innate gases. So that's what we have, the innate gases. So by just looking at the table there, you are not required to know is it argon, is it helium, is it what is it, neon. You're not required to do that. Now you're just going to use these letters. Now write down the imaginary symbol. They put it in bold so that they know. Some of you know very no, this is J, is a group 7. So maybe you're gonna say no, I think it's fluorine. Then you come and write fluorine. They know. You are just gonna use the what you call the letters that you are given. So use the letters, imaginary symbols as given above. Which one is what you call halogen? So halogen, your group 7 is your J. So it's your J. Then we will form a cation with a charge of 2. So this one is a metal. It will lose how many electrons? 2 electrons. It's in group 2. So only group 2s do that. So that's your E. Then here's the highest atomic radius. Now, what do we know about atomic radius? We say atomic radius decreases going to the right, but decreases downward. So it means that the one, sorry, man, decreases across the period, but increases what we call down the group. So it means that our A there is actually our right option, because we are saying it's actually on the, what is it, on the metals which have got what is it, high, or should I say big atomic radius. And again, it's down the group here, means say atomic radius increases down the group. So it means that that's our A. I have high electron negativity. This one have high tendency of attracting electrons. So that's what you have, what called the J. It needs electrons. That's your, remember we said chlorine, fluorine, they would rather gain 1 electron than losing the 7 electrons. Now, metalloid is our H. Remember, it shares both metals, both metals and nanometals properties. Noble gas is our last, it's our L. Then will form a diatomic molecule. This one, it forms a diatomic molecule, and we know that this is a what called one property of what is it, our halogens. They actually share what call covalently. They share the electrons, forming diatomic, like chlorine 2. When I'm saying diatomic molecules, like chlorine 2, iodine 2, but also oxygen as well. So we can take the G and what, and J. That's those are our 2 answers. And here's 3 valence electrons in group 3. We have got D. Then define the term first ionization energy. First ionization energy. What do we know about first ionization energy? We know that this is the energy needed to remove, because they're saying first to remove 1 electron from an atom in gas state or gas phase. So that's what we need to understand here. It should be in gas phase. The electron should be in gas phase. And we are saying it should be, you must state that it's losing 1 electron. Now, first ionization energy of element A can be represented by the following incomplete equation. AgA plus 400, you don't need to kilojoules per mole. But now, what do we get there? We know that it's going to lose 1 electron. So it's going to be Ag is going to give us Ag plus 1 electron. That's what it loses. So that's what, simple as that. That's the equation that you are required to know. We are just completing the equation here. From this is the whole equation here. Now, atoms of element J release the most energy when gaining electron to form negative ions. Write down the one word or the term used for this is what we call electron affinity. So we know that these guys have got high electron, what we call high affinity tendence to take electrons. Now, here we are saying write down the formula of the compound formed when D combines with G. So this one here, remember, it's your group 3. Group 3 combining with what? G, which is your group, group what? Group 4, group 6. Now, this group 6 here, is your oxygen. So these are your oxides, and you must always remember this. And in your group 3, you mainly have aluminum there. But we are not worried about that. We know that they form in a ratio of what? In a ratio of D to G3. That's what we know. It's in the ratio of D to G3. So for example, also aluminum, what is it? 2 oxygen 3. But remember, this is not required, not needed. You need to write in the form of what? In the form of D and G. That's your answer there. So that's your answer there. Then A combines with G. A is a group 1 with G. So A is going to delete 1 electron. So A, for example, we're just going to give an example. I'm not saying it's the correct one, but we're just going to say in that group 1, we have things like what you call potassium. Potassium only lose 1 electron. Then there is chlorine. So we know that it's going to be AJ because it's 1:1. They're in the ratio of 1:1 because your chlorine, your potassium loses what? Loses 1 electron. Your chlorine gains what you call 1 electron to become your chlorine negative. That's what we know. So it's in the ratio of that. So this is just for you to understand, but we don't need it. So this is your answer there. So guys, I hope you guys understand. So always remember, when they tell you to use imaginary symbols, don't try to come up with your own symbols. We don't want, it's not needed in that case. What's needed is to actually follow the instruction. Okay, thank you so much.